Super excited to have you guys here. I'm super excited to be here to present AWS DevOps in practice. So thanks a lot for taking your time out. I know that it's difficult to get away for trainings and things like that. And I know that I sign up for webinars and sometimes I don't get a chance to join. So the fact that you're here means a lot. And I want to make sure that we deliver something really good for you today. So the game plan is to give you a really good idea of how can you get started here? What's DevOps look like in AWS? And what are some of the things that you should be thinking about as you continue to move forward with AWS and get into actually implementing DevOps and doing things like infrastructure as code and building release pipelines? There's a lot of people that are talking about this these days, and a lot of conversations have been going on in the last couple of years about DevOps. For some people, it means different things than other people. And so this webinar is really more about what's the tactical stuff? What does it look like in practice? So we're not going to do a lot of theory so much. And I'll make sure that we're all up to speed a little bit here with some slides. But my goal is really just to live in the tools and give you a real clear picture of what DevOps might look like for an application that you're going to build and release and continue to support in the AWS environment. So pretty exciting in terms of the opportunity in the DevOps space. I know some of you on the call are already doing DevOps and maybe doing infrastructure as code and continuous delivery, things like that. And for some of you, this is a brand new thing. You're kind of getting started for the first time. You're wondering if DevOps is a career move that might be interesting for you. And for those folks that are new to this and are kind of thinking about this, I'd like to say that, fan that flame of ambition, because the reality is we need your help in this in the industry when it comes to doing DevOps. There's a lot of opportunity out there, but the reality is there's not a ton of people in the job market that have the skills that we need. So I would encourage you to, it's a big takeaway from this talk really is to, if you're thinking about doing this, definitely, there's a huge opportunity to do so. And what we're going to talk about today is really going to give you, I think, a clear path, clearer path than I had when I was coming up in the tech industry. So as Daniel mentioned, I'm a former Microsoft engineer, and I was a solution architect at AWS for a number of years. So definitely not my first rodeo, but I can tell you from doing web development and infrastructure work throughout my career that I wish that I would have had a clear path to follow, and the industry had been kind of where it's at today. So very cool stuff that we're going to do here. And like Daniel mentioned, I'm excited to answer your questions at the end of this webinar. And so please go ahead and, as we're doing stuff, if things pop up in your head, go ahead and provide those questions in the Q&A box, and then we'll get to those if we can at the end, if we can get to all of them. If we can't get to all of them, I'd like to encourage you to hit me up using the information below. So there's my Twitter handle, there's my LinkedIn information. So if we don't get a chance to answer your question, feel free to connect with me. I'm real big on community and networking. I will answer every single tweet and DM because that's just kind of how I roll. So definitely hit me up, let's connect. And I'm always sharing stuff that I find interesting in this space, in the cloud computing space as well, with other platforms on top of AWS. So with all that, let's kind of dive in and get started here. So just wanted to cover some quick DevOps principles. I think most of you guys on this call probably already get the idea here, but from a high level, let's just kind of make sure that we got the context and we're all kind of on the same page. So really the idea of DevOps, one of the core principles, right, is to break down the barriers between teams. There was, in the past, there's been, silos of teams, developers, operations, and being in those different teams, there's been a little bit of a disconnect in some places where, software developers are throwing code over the wall to the infrastructure team. Infrastructure team is trying to figure out how to deploy it. So, really the big thing about DevOps is working together as a team. Developers learning more about infrastructure, and the infrastructure folks really learning more about the application, how it works. And then, of course, there's, the culture and the processes that go into all of that. But really the idea here is more about, collaboration and really understanding and appreciating the world of the other people in our teams. And so if I could really express one of the biggest things here that has really been good for me in my career is to really have that perspective, to be able to, if you're an infrastructure person, understand the perspective of the people building the code for your team and vice versa, right? If you're a developer, really understanding the perspective of the folks that are deploying and supporting those applications for you. And getting an understanding of, how can you fit in there? How can you do maybe a little bit more outside, your traditional role as a developer or as an infrastructure person to kind of plug into these different places. And I think as we get into the demos and stuff, you'll get a better idea of that. That's kind of one of the core principles. On top of that, one of the biggest things that you hear about a lot with DevOps is really the concept of completely embracing automation. And this is something you're going to see as we get in and take a look at this in practice. We've got the ability to completely automate everything on AWS because the whole platform is completely programmable. So not only can we automate the deployment of the application and the infrastructure, but we can automate the software delivery lifecycle as well. So that's going to be a big part of this. Everything that we do kind of in this demo, you're going to take a look at, that's actually a practical application, completely automated from both the application code and the infrastructure. Kind of along with that, another core principle of DevOps practices is testing and versioning not only application code, but infrastructure code as well. And for a lot of folks, especially on the developer side, that's not a new concept. You're used to checking in code the version control repositories and running unit tests. But if you're an infrastructure person, this can be kind of a new thing, declaring your infrastructure as code and actually testing that code, and then automatically deploying resources based off of infrastructure code templates. And so that's going to be something that we take a look at on both sides here as we get into seeing, like, how do we collaborate as a team to build an application that is something we can test, it's reliable, we've got confidence in everything, and we've also got security and controls and monitoring. That's kind of the last point here. It's interesting, since everything is completely programmable, we've got deep controls from the identity and access management perspective as well. We can do role-based access control and use the IAM service in AWS to really make sure that only the right people have the right permissions. And so one of the things I'll point out as we get in here is, you could enforce a kind of a policy and a framework, if you will, that everybody has to go through version control to make changes to the application, even the infrastructure team. So that's something that you could do to increase the reliability and the security of your application. And of course, monitoring, measuring the results, that's all stuff that's super important in terms of core DevOps principles. Fortunately, all these tools and services that we have on the AWS platform, there's native capabilities for everything that we just took a look at here in terms of doing automation, security, and monitoring. And then there's also third parties that can plug in as well. So game plan for today is really just to show you the native services that are available on AWS to do all these things, show you a practical example of basically a release pipeline that developers can contribute to the version control repository. Those changes are automatically built and tested, and then potentially deployed, and then that infrastructure that's supporting the application is also automated and put in a version control repository. So that is the game plan. And so I'm kind of challenged here in terms of being able to go super deep for a long time, because normally this is something I do in a 4-course series here on Pluralsight. It's like 16 hours to really go through all this kind of stuff. So my goal is to give you some perspective with this, so you have kind of an idea of how this works. And then I'm going to give you some resources when we get into Q&A and towards the end of the call that you can take and go deeper. So let's start off and talk about continuous integration and continuous delivery. You hear people talk a lot about CI/CD pipelines and that whole process. That's a big part of practicing DevOps, right? So let's take a kind of a step back here, just for everybody, in case you're not a software developer or really have had any visibility into this world. So, part of the big thing with DevOps is applying software practices to infrastructure. So if you're an infrastructure person, this is going to be an important concept. So continuous integration, this is one of the things that's allowed some of the biggest software companies in the world to really move quickly. If you've been around for a while, you've probably noticed, folks like Amazon and Microsoft are moving fast. It's crazy, right? It's new stuff coming out constantly. Whereas before, several years ago, back, especially when I came up, it was every couple of years there would be a new version of software. Now it's like stuff's changing almost every week. There's features that are changing and things like that. So one of the big things that's enabled that is really this whole concept of embracing automation breaking down the barriers between teams and using a continuous integration and continuous delivery workflow for everything. And so this is something the software developers have been doing for a long time, and that's kind of what we're looking at here on the screen. So you got your application developer. You might have multiple developers contributing to the code base for an application, but essentially those developers in a continuous integration model are doing incremental changes to the application code. They're committing that code into some kind of version control repository that's shared amongst people on the team. And they're getting fast feedback because we've got this continuous integration server on the right-hand side of the screen here that you see. And so there's a variety of different platforms that do this, provide this type of functionality. But the idea is the continuous integration server is looking at the version control repository. The developer makes a small change to the application. Inside the continuous integration server, we can have that thing go grab the code out of the version control repository, maybe try to compile that code if it's a .NET or a Java-based application, or if it's a Node application, maybe it installs some app dependencies and does some other things. But we also have the concept of running tests during that build process. So unit testing, making sure that the code does what it's supposed to do. So this kind of workflow here gives the developers fast feedback. Like, is my change actually working? Is the code compiling? Are the tests passing? And it allows the team to move faster, right? If there's an issue, they know about it right away. They can address it in the code, make the adjustment, and kind of move on. So the interesting thing about moving into DevOps, and I'm going to advance this slide, and it's not going to change much. You've noticed that we have kind of the same workflow now, but instead of a developer, an application developer, we have an infrastructure developer. So what we can do here is apply the same pattern to the infrastructure, especially in AWS, where everything's virtual. All we got to do is make an API call or use a variety of different tools, and we can build all the infrastructure we need to support an application. So in that model, and when we're talking about embracing automation and really leveraging all the DevOps principles, the infrastructure developer can basically write infrastructure as code and commit that code into a version control repository as well. One of the common patterns that you'll see is that with the application code, the folks on the infrastructure side will also have an infrastructure template in that version control repository. So in the world of AWS, there's a service called AWS CloudFormation, and it's really just a way for you to build a template of what your infrastructure should look like. Basically, how many servers should you have? What's the network configuration supposed to be? What storage resources do you need? All that stuff goes into a declarative template. And when it comes time to deploy those resources, you just feed the template into the CloudFormation service, and it reads the template and goes off and builds everything. It's very cool. Some of you guys, I think, could probably work with that service a little bit. And then there's also other tools that do something similar. If you might have heard of Terraform, which is another, infrastructure as code third party, which works with multiple technologies, and they've got providers for AWS. But that's basically the idea. So when you're doing continuous integration for the infrastructure side, the infrastructure developer can build those templates, put it in a version control repository, and again, the CI server the continuous integration server can see those changes going into version control, right? So the infrastructure developer commits a change that triggers a build. And, in an infrastructure scenario, a build might not make sense for a JSON or a YAML-based template, right? Because there's no reason for us to compile that. But a build might do something else in an infrastructure pattern here. You might build some virtual machine images, for example. So if you think about the scenario where you're hosting an application on an actual virtual machine, sometimes you've got to install a bunch of dependencies inside a virtual machine, and it can take a long time for that virtual machine to come online. And so what some folks do is they'll basically bake their images. And what we mean by that is building custom images with all of the stuff installed inside the virtual machine image. So you spin up the virtual machine, and it's got everything you need. And so one of the reasons why sometimes people will choose to do a build of virtual machine images for continuous integration is just to get that image set up and ready to go. And it's got the latest updates because we're using, kind of a brand new image from AWS. We install our application dependencies inside the virtual machine image, and then we bake an image that we can use. It's got everything installed in it. It's got the latest and greatest updates. Testing in this workflow for infrastructure templates can also be interesting, right? You could have some code in here that actually validates your templates. I've worked with a lot of customers that, will basically scan those templates and run some tests against them just to make sure that they don't have weak security group rules for their infrastructure. So they're not exposing like SSH or RDP to the entire internet. If they see that in the template, they'll fail to build. So there's a lot of use cases here for not only validating that the syntax is correct for the infrastructure template, but also checking what's going on inside that infrastructure code. So it's definitely optional. Don't have to do that, but it's very interesting that you can, right? So you get that same reliability with your infrastructure code, just like you do with the application code. So moving on from CI, so you hear the term CI/CD pipeline, right? So continuous integration, we just took a look at that. So what does continuous delivery actually look like? Well, in terms of continuous delivery, and when you're doing, embracing DevOps and everybody on the team is kind of following the practice, this is kind of high level of what we're going to take a look at. And it's a very common architecture here. So, if you read Amazon's or AWS's DevOps guidance and some of their white papers and some of the things that they share about their learning process of supporting a retail business over the last 20 or so years, they kind of give some recommendations in terms of how to do DevOps, because it was something that they had to learn how to do very early in the life of their business, and then they had to build a bunch of tools to support all that automation. One of the obviously one of the most successful things they built to support their retail business was AWS itself. But then once they had that, they started building other services for the teams writing software inside the company to support the retail business, and now they sell those services too. So what we're looking at here is the continuous delivery pipeline. So we've got the 3 different teams. We got an application team, we got the developers of the application, we've got the infrastructure team, which is the developers of the infrastructure code, and then we've got a tools team that's responsible for basically gluing together this whole pipeline. Basically defining where is the version control repository live, how are we going to build, and test and validate all the code in there, and how are we going to deploy it. And so those are the native services that we're looking at here on the slide that are available in AWS. And these are the services they built internally years ago to support the retail business that they eventually said, hey, this is kind of cool, we should sell this, right? And that's what they did. And so those are the services that I'm going to show you guys today. And I'm going to show you basically how a team doing all these 3 things could build an application and support an application completely built through code with the ability to test at every level, secure and monitor the entire application. But basically the big takeaway here is we're doing continuous integration and continuous delivery. So the development teams for both the application and the infrastructure are committing code to a repository in AWS Code Commit. AWS Code Commit is basically a Git-based version control system. So if you've ever worked with GitHub, you know that GitHub hosts version control repositories based on Git. And so Code Commit is very much like GitHub in a way, right? It's a way for you to put your Git-based version control repositories in a central place. You can use the AWS Identity and Access Management security system to basically secure access to the version control repository. And then we've also got other native tools inside the platform like AWS Code Build. So Code Build is going to be a managed continuous integration service that you can use. So you don't have to spin up your own continuous integration server or build, buy that from somebody else. That's basically available in the platform. And so what we can do here is put both our application code and our infrastructure code in a code commit repository. We could use GitHub and we could use something else if we wanted to, but if we're talking about native services, we put it in code commit. And we basically build up this workflow where when code comes in and changes are committed to that control repository, the code build service will go grab that code and do what we were just talking about, run a build, run some tests. And then finally, kind of the big last piece is where do we deploy that code when it's done? Because that's kind of the idea with continuous delivery. The idea with continuous delivery is really like combining the continuous integration with, do we have a version of the application that can be released in production? Does it function? Maybe we deploy the code that comes out of that, the artifacts that come out of the build. Maybe we deploy that to a new environment and just test it and see that, is this going to work? We can go run some tests after the fact, performance tests, integration tests, UI tests, things like that. So it doesn't necessarily mean we're rolling the code straight into production, although we could if we wanted to. So really the idea with continuous delivery is making sure that we've got a deployable version of our application, and that deployment may be a manual release, right? So that kind of brings up the question of, you hear people say, CD. Are they talking about continuous delivery, or are they talking about continuous deployment? And really, what are the difference between the two? And the big difference really is shown on this screen here. There's one big difference at the end. It's taking the application, the output artifacts from your build, and knowing that you've got that code that's ready to go to production. In a continuous delivery model, that's not an automatic release into your production environment. So that could be a manual step where you say, okay, this looks good. Let's go ahead and release it into production, or let's release it into another staging environment for more performance testing. And the opposite is true for continuous deployment. So when you hear continuous deployment, that really is like the whole pipeline's automatic. We're making a change. It flows all the way through all the stages, and it just goes into production. Okay. So what I'll show you today is technically going to be continuous deployment, but I'll show you some different ways where you can kind of override this. So that's the high level stuff you need to know to understand the demos that we're going to go through. And what I'm going to do now is going to switch back over here to the AWS Management Console. And I'm going to show you guys kind of all of that in practice, what I just talked about in the slides. So if you're new, this is probably going to seem like a lot, but I'm going to give you some resources at the end where you can take things a little bit further on your own and go kick the tires of some of this stuff. So you will be able to kind of mimic what I do in these demonstrations and test this out on your own. So one of the things I want to point out here in the AWS Management Console, if we scroll down, there's always a huge list of services here, right? The developer tools is going to be where we're living. Code commits, code build, code deploy, code pipeline. One of the things that I didn't really mention on this previous slide, let me just go back over here real quick. The code commit, code build, and code deploy are all orchestrated by this code pipeline service. And I'm going to show you that, but code pipeline is the, kind of the orchestration service that you can use. You don't have to use it, but you can use it with all of these other services to build this automated workflow, okay? And so those are all available in here. And AWS has recently updated the portal here, so it's a little bit easier to work with. You can see on the left-hand side, we've got the source code, we've got our build service and code build, we've got code deploy, code pipeline. And so I'll be poking around in these different ones here. But basically the kind of getting started piece is our code repository. So we have a Node.js demo application in a code commit repository, right? So we're looking at AWS code commit. We've got some source code here. So let's go ahead and take a look at the code for this application. This is just a basic web application, a node-based web application. And the way we have it set up right now is it's just going to deploy this code for the application to a single EC2 instance. Okay, so what this software has already done is it's built a virtual machine out here. It's got this sample application running here. It's super basic, but all the code that we have in code commit is supporting that. So not only is it deploying this web application, it's deploying the virtual machine through an infrastructure template, and then the source code for the node application is here in code commit. All right, so let me show you a couple things first. So in this public folder, there is the actual front end of the application, right? So we've got the index.html file. And so really the idea here is, if I'm a developer, I've cloned this repository on my machine, and I could open up this code locally and edit it, and then I could commit that code back to the repository. And depending on how I have things set up, that could kick off a build and run some tests. And then it could also release that application and deploy it to my EC2 instance. Okay, so I'm just going to do it here in the portal just for ease of use. I'm not going to clone the repository and work with it locally just in the interest of time. But I can edit it here in the code commit portal. I can scroll down and notice there's a message that says this is version 2 of the application. I can change that to this is version 3 of the application. I could scroll down and I could commit those changes to the master branch of the repository. So in this demonstration application, I only have one branch, just the master branch, but sometimes you might be working out of another branch and then later maybe merge those changes into the master branch. For now, I'm just going to put this in here. and then put my name and email address, and put a commit message, something descriptive like I updated the index.html file. Okay, and so the cool thing about this is that if you haven't worked with version control, this change is going to be tracked. I'm going to know who did the change. I'm going to know when it happened. I'm also going to be able to see what changed from one version to the next. So what was the code before and what was it after this commit? So if I do a commit here, that's essentially the same thing as me working on my developer machine and pushing a local version after I do a commit here into AWS Code Commit. Now, if you go over here on the top right and you click on View Commit, it's pretty cool. So we can see who did it, right? We've got the author. We've got the commit date, says just now. If I'm coming in here a week later, I'm going to see the date and time, of course. We see the commit message, which hopefully the people on the team are using good messages about the changes that they're making. And then if we scroll down the bottom, we can see the change, right? So we can see that previously it was version 2 of the application. I made a change to say this is version 3 of the application. Now, the cool thing with this as well is that right now I have all of these services tied together. I've got code commit set up to work with code build and code deploy because I'm using the code pipeline service. So I'll show you how that's put together. And I'll also show you how to do this exact demo that I'm going to show you as well. But the nice thing here is we're basically doing continuous delivery or continuous deployment pipeline, I should say. So what I'm getting at is this change that I just made that says this is version 3 of the application will eventually just show up right here on this page without me doing anything else, which is very cool, right? Because we're just making changes and we're very quickly getting them into this environment. So whether this is a test or production. So that's kind of the idea with the code commit setup. And I'm going to come back to this, but I also want to show you some of the code inside the repository. Let's go back over to this node demo repository. So, the app.js, the tests, the scripts, all this stuff here, most of it is for the node application. But if you look down at the bottom, we've got things like the template.yaml. We've got a build spec.yaml and app spec.yaml. So these YAML-based configuration files are really what tell AWS, how do we automate things like deploying the infrastructure? So in the template.yaml, this is actually a CloudFormation template. So it's right there in the same version control repository with the node application. And we're going to actually use that to deploy the infrastructure. So that's actually how I created that EC2 instance. And so the way that I've got code pipeline set up right now is that the environment didn't exist, and I made a commit to this repository. It would use that template to spin up the infrastructure. And also, the way I have it set up right now is if the infrastructure is deployed, we're just going to do updates to the infrastructure. So if I change the template here, if I come in and modify the template, commit that template change into the repository, we're going to do the same thing. We're going to update the existing infrastructure. So let me show you what I mean. So for example, looking at this EC2 instance and scrolling down, we've got some security groups here, right, that control who can get to the application. If you're looking at the rules, we've got an HTTP rule that says anybody on the internet can go to port 80, right? We'd want that for a web application. Just underneath that, we have an SSH rule where the source is actually set to a specific IP address. And what we could do, in an infrastructure as code model, we're practicing DevOps, instead of coming in here and changing this stuff because, I can't SSH, it's not working, we can actually enforce those changes to happen through code. And so in the code commit repository, what we're looking at here, it looks like, basically a bunch of spaghetti code. And this is a YAML-based CloudFormation template. It's very verbose, but at the end of the day, this is just declaring what does the infrastructure for the application need to look like. And so I'm not going to get into how do you write these templates because I could spend a week on that. But if you look underneath resources, what they're doing here is they've defined a web application server. It's basically an EC2 instance. There's all the configuration, the bootstrapping code. We've got a bash script that runs, and the code is embedded for that. So when the EC2 instance spins up, it's going to kick off this bash script. And so we're doing a bunch of automation in here. But down at the bottom as well, the infrastructure settings are also available. So for example, the security group, right, that we were just looking at in the portal, we actually see those ingress rules in code down here. So if I was going to change the SSH rule, for example, instead of doing it just, kind of on the fly in the portal, I could change it in the infrastructure code, commit that code to the repository, and then have the pipeline actually make the change. So not only is it traceable and kind of a way for us to audit that through the code commit repository, we can see who changed it, when they did that, what was it before, but we also have the opportunity during the build stage to test it and things like that. So what I'll do here is I'll just edit this template. And then instead of 8.8.8.8, I'll just change this to, let's say my team was going to be coming from a different IP address to SSH into that server, so I changed the IP. Would provide my information again, and then it would say, updated the security group with the commit message and something, detailed. You get the idea, right? So cool thing is both these changes that I've done are going to flow through that pipeline and eventually just go into the existing resources that I have. So this one's going to take a minute, but if I come over to example app, notice it says this is version 2 of the application, and I hit refresh. It says this is version 3 of the application. So while I was talking about the infrastructure code, that change that I made to the code commit repository to change that string, basically, it went through code commit, it went through a build process and a code build service, and then we released the new version of the application to that running EC2 instance. Pretty awesome, right? So let me go back over to our code repository here. Go back into node demo. We've got some other files in here. So the template controls the infrastructure, just like I mentioned. And we've got the build specification, which is another YAML file. This really is just telling AWS in the code build service, once we commit code to the repository, what do we do with it? Like what steps, what commands, what things do we need to do? So if you take a look at this YAML file, it's the build specification for code build. It kind of just goes through the process. Like, what are we going to do when somebody commits a change to the repository? And so basically what it's going to do, there's going to be a managed build server that pulls the code from your code commit repository. And then it's going to run these commands. It's going to do a build and run some tests. And then it's going to give you your output artifacts. Those artifacts are what you can then deploy the application with. And so in code build, there's, of course, managed servers that are doing this for you, but you can also build your own Docker container. So if you need certain software available inside that little build environment, you can customize that. This one is doing something very simple. If you look at the phases, we've got an install phase and some commands. So imagine this, I change the code in the HTML page, commit that to AWS code commits. That tells code build to grab that code and then do these things. So it's going to basically clone the repository. It's going to run an npm install to install the dependencies for running the unit tests and some other things. There's another command in here to upgrade the AWS CLI. It's by using that for some stuff. And then it's doing some other things, like it's running npm test. So inside our version control repository, we've actually got unit tests for that node application to make sure that it's returning a congratulations message. And so this is just basically forcing that test to run to make sure that that's going to happen. So not only are we making sure we can install the dependencies for the application, we're also testing the application code. And then after that, we're just doing some post-build stuff. We're cleaning things up, getting rid of modules that shouldn't be deployed as part of the kind of production application source. And then finally, down at the bottom, after we do a few other steps, we've got this artifacts option here. And you can see that it's basically going to give us a zip archive. It's going to bundle up all of our code. We know that it's tested and it works. So let's go ahead and bundle it up. And what we're saying here in the files is what files should go into that archive, because the archive is then going to get passed to the server so we can deploy the code. Okay, so what will happen here with code build is actually going to bundle up this application, put it in Amazon's S3 service, which is object-based storage. And then we're going to tell the code deploy service, which is, of course, the deployment service, hey, there's a zip file out in S3, so go grab that and then go install the code, set up the application on the server once we've updated the infrastructure, if we need to do that. So going back into the repository here, to show you real quick, we've also got an app-spec.yaml file. And this is the instructions to the code deploy service, like what should it do with the code? So it's gone through tests and everything. And so now go grab the code and unpack it and deploy it to certain spots. So we can see that we're targeting a Linux-based OS here. And then under files, this is telling the code deploy service, hey, grab the app.js, which is the application the node-based application in this scenario, put it in this folder, do the same thing for the package.json, put the front-end code, the HTML and all that in this folder. And so it's giving us the ability to be very prescriptive as to where those assets need to go on the server. And, of course, I could have multiple servers in there. You can even deploy code to, services like you might have heard of AWS Lambda, which is serverless compute service. You can basically build applications that use other things other than virtual machines. So just don't want you to think that you have to use virtual machines for everything. But notice down here, there's some hooks as well. So this is also something the code deploy service that will help you with, because essentially what's happening is the code deploy service is going to have some agents that get installed inside your virtual machines. You can also use it with on-premises servers, which is actually really interesting. So as long as that agent is installed on any of your servers and you've got things set up correctly, you can deploy code to those servers. And so, we know that based on the file configuration where the code is going to go on the system, but then, these hooks, we can actually tell the code deploy agent to go run scripts. So we've got a script called install dependencies, start server, stop server, and those are actually in our source control repository as well. And so if you look in here, there's scripts. And if you look at like install dependencies in that, imagine that we've committed a change, it's gone through the build, and now we're actually on the computer installing the software. It's going to grab the files out of the zip archive, put them in the right folders, and then it's going to run the scripts, install dependencies. So it's basically installing Node and getting that up and running, right? So we don't even have to have the software baked into the image. It could be part of the installation process in code deploy. So that's in there. There's also some stuff like when you're starting the server, basically just configuring the ports that you're going to listen on for the Node.js application. So this is all just bash script in this example, so you can put whatever you want in here. That's really the biggest thing, which is really interesting. Now, I just want to show you guys a couple other things here in the console. So let me collapse source code and go into the code build. You can see my build project. So we looked at the build configuration, but here is the actual build project for my Node application. So we've got the build history. I've done a few updates today, so you can see that all these were successful. And if you actually drill into this, you can get the details. So you can see what happened. You can scroll down here and see the outputs on the build agent. So the machine that was actually running through the build process based on your build definition, it's showing you all the output. So if there is an error in here, you come in and it's like failed. And you're like, well, I don't know what that means. You scroll down here and inspect the output and then start troubleshooting, right? So that's kind of the essence of code build. And if I had more time, I would go deeper into this, but that's from a high level, really kind of the idea. Underneath code build, we've got code deploy. We'll come over and take a look at our deployments. And you can see that I've had several deployments run today. A couple of the interesting things I just want to point out here. Notice that they have a deployment type. So this code deploy service, this is actually a really cool service because it gives you very deep control in terms of how your code actually gets rolled out. Notice that you've got different platforms that you can target. So in this case, we've got EC2 on premises. But in terms of a deployment type, an in-place deployment, those are the ones that's where you're just taking existing infrastructure and updating what's on that infrastructure. So take the existing EC2 instance and maybe update the application code. But one of the more common patterns these days is to do brand new deployment, right? So you've got version 2 of your application, and instead of just trying to update the server, you actually build brand new infrastructure that mimics your production environment, same exact configuration. And then you can either test or actually roll that new infrastructure right in. So instead of doing an in-place upgrade, you could deploy this to brand new pristine systems, and you can be confident that you're not going to carry over kind of a bunch of junk. Because I don't know about you guys, but I've worked in environments where servers have a long lifetime and they're there for 5, 6, 7, 10 years. And you know how it gets, right? After a while, the server's just like been beat up. So sometimes it's really awesome just to like build brand new servers as part of the deployment process. So I would encourage you to really take a good look at that service. There's a lot we could do with it. Unfortunately, I don't have time to go any deeper with that, but I do want to show you the deployment pipeline. Okay, and so this is kind of like the big piece of the puzzle here. We've used the deployment service, or the code pipeline service, I should say, to kind of glue all these other services together. And this gives you a really good way of actually see this kind of visually, right? So, excuse me. So this is cool because we can actually customize this workflow. So it doesn't have to be, a strict or model exactly what I've been doing. But what you'll notice here is we've got the source, where that's where, we're actually looking at the version control repository. 8 minutes ago, we saw a commit come in, so we basically grabbed that code. And we had a transition that sent that code over to the code build service. That build process ran, it was successful. We spit out some output artifacts. And then down here, we were basically going through and updating the CloudFormation template in case there was any infrastructure changes. So you saw me change the IP address 6 or 7 minutes ago for this security group over here. Remember, I went from 8.8.8.8 to 4.2.2.2 or something like that. So if I refresh here, notice that the IP address on the source just changed. So that change flowed through the pipeline, which is really cool. And then down here, we've got the final stage after we've updated our infrastructure to actually deploy the code. And we saw that when we were looking at the example app, we saw it went from version 2 to version 3. So those are the native DevOps services. And that's what a release pipeline, a CI/CD pipeline for both application code and infrastructure code would look like on AWS. The last thing that I want to mention is if we go back to the console home, well, actually 2 things I want to mention. So number one, if you want to basically run through this demo, kind of mess around with this environment, find CodeStar on the console home screen. And this is kind of like a collaboration service where your whole team can work with. And what I did is I actually used the CodeStar service to build this whole thing up. And this is an awesome way for you to build a pipeline and then reverse engineer it for your own work. And so I came in here, created a new project. And what I did was I picked this guy here, this Node.js project with EC2. Let me go back real quick. I should have clicked on that. I picked this guy here, Node.js web application on Amazon EC2. But notice there's all kinds of different stuff. So if you're not a Node person, you're more of a Java person. There's even .NET stuff in here, Python, PHP. You can build out a reference architecture. You can actually see it in action. You can go in and dig through all the configuration files. AWS has awesome documentation, so I'd encourage you to look at that as you're working through this stuff. And in order to do this, what I did want to mention is these tools that I was showing you are available under the free tier. So if you haven't heard of this, if you sign up an AWS account, you've got these free tier credits for the first 12 months. And if you take a look down here, you get 100 minutes of AWS code build for free every month. You get 1 free active code pipeline, which was the orchestration service I was showing you. You get some 5 code commit users. So you do get some free credits with these services. So you can go in and kind of play around with it a little bit. But also they give you some credits for EC2 infrastructure and things like that. So that's my time, you guys. I wish I could keep going, but what I got to do here is basically pass it back over to Daniel. We're going to kick off the Q&A process.
Awesome. Thank you so much, Mike. That was, such a great presentation so far. Like you mentioned, we're now going to begin the Q&A process. And so one thing real quick, some of you on your screen might still see the presentation window where Mike was presenting. You can just go ahead and minimize that, and then that will free up your screen so you can have access to that Q&A chat box. And yeah, we'll kind of take it from there. Mike, are you ready to dive into some questions?
Yeah, I sure am. So kind of go through here. There's the first question that I think is a big one and a good one to ask is, which is the best AWS certification to start with for somebody as an automation engineer, DevOps engineer? So a couple things here. Number one, AWS used to require that so the AWS DevOps certification is a professional level certification. Typically, it's not intended for that to be the first thing that you go into. But AWS has lifted that requirement for you to go through an associate certification first. So number one thing to point out is, like, if you feel like you've got the skills to just go in and take the AWS DevOps professional certification, there's nothing stopping you from doing that. But if you want to kind of go down a path and get started easily and then work your way into DevOps, because the reality is the DevOps exam is the most difficult, the most comprehensive, but also like probably one of the more valued in the job marketplace. then you'd probably want to start with an associate level. So it really depends on like what's your path. Like, are you coming from a developer background, and are you going to continue to write application code for actual web projects and things like that, or are you an infrastructure person? So that would be the first question: is like, where are you coming from, and where do you want to go with your career? Like, what role are you going to play on a DevOps team? Are you going to be building apps and also doing some infrastructure stuff, or are you going to primarily be a person writing infrastructure code? And so I think that's what drives the associate certification. So if I'm somebody building applications, I would do the AWS Associate Developer Certification and then maybe graduate up to DevOps. And kind of go from there. If you're more of an infrastructure person, you can do Solution Architect. I think that would be really good. They have a SysOps Associate Certification. But I think there's a lot of value in the Solution Architect Associate because it really will set you up with a good level of knowledge in terms of how things are built. So you can't go wrong with any of those two paths. It's a great question. Kind of moving on to the next question. Let's see, what is the cost of AWS code commits, code build, code deploy on AWS? Yeah, so basically what I would do there to determine your cost once you're outside of the free tier, AWS has every service has a service homepage. So for example, if we were going to take a look at Code Pipeline, this is the service homepage for Code Pipeline. There's always a pricing tab for every service. So if you come in here, oh wait, you guys can't see my screen, can you? But I forgot I was not sharing anymore. But basically, you can go to the service homepage, and for any particular service, there will be a pricing tab at the top. And remember that it's free if you're just kind of playing around under the free tier. All right, so the cost will be in there. They also have calculators for AWS. You can also just search for the AWS calculators and kind of go through that. So we answered the questions about, is it free to use? How do you install and make dev tools work on premises? So yeah, that's kind of a broader question. If in terms of code commits, you can configure your on-premises machine, your developer machine, to be able to authenticate to the code commit service via like an IAM user. So you'd have to install, you'd have to have Git obviously on your local machine and then set up your credentials, all that kind of stuff. In terms of some of the other things, like if you're talking about code deploy to deploy code to servers on premises, you just have to install the agents and make sure those servers are given permission to the IAM framework there. Question about the CloudFormation. What was the execute change set step? That's a really good question. So, with CloudFormation in the early days, all we really had was a concept of, well, in the very early days, we just kind of like build the template and then delete the infrastructure when you're done. So a change set allows you to modify different portions of the infrastructure by updating the template, basically. And so that way you're not redeploying a brand new version. So if you saw me changing the security rules for EC2 instance, it gives me the ability to just change the settings and not redeploy the entire application. Let's see, next question. Do we need the deployment environments, like integration, staging, things like that? Well, that kind of depends on what your goals are. Some people have a more robust pipeline. They might have, staging, development, maybe, a couple others. It just kind of depends on how much testing you want to do. There are ways for you to inject other stages or build other stages in the code pipeline. So, you could say, all right, we deployed some infrastructure, but let's go off and run some performance tests, some UI tests and things like that. And so that might be in one environment, and then you deploy to a dev environment to have some people actually go in and test it. So it's really up to the organization. And so there's really, no requirements there. It's based on what you guys' goals are and how you want to do things. Where do you recommend somebody starts if they're evaluating a transition into DevOps, but for on-prem versus cloud? Where do you recommend how to start? Okay, yeah, it's a good question. So, if you're transitioning into DevOps just in an on-premises environment, I would focus on getting some automation skills. And I would also do what I was talking about earlier, start to understand and appreciate the world of the other team. So if you're an infrastructure person, or you're maybe working in a help desk right now and you want to get into like infrastructure development, more of a DevOps role, I would learn some scripting, right? So I would try to figure out like maybe learn how to do some bash scripts or some PowerShell scripts if you're in a Microsoft environment. I would also start trying to figure out what's infrastructure as code and how can I start building templates for that. So you could work with things like Terraform, which is from a company called HashiCorp, which basically allow you to do something very similar with CloudFormation, but you could basically target like your on-premises private cloud, right? Your virtual machines and VMware and things like that. And then if you're a developer, then I would just get more experience around building and setting up infrastructure, load balancers, and understanding, systems architecture, performance, storage, networking, things like that. But yeah, so if you're an infrastructure person kind of moving into DevOps, get some scripting skills and also maybe get some awareness around like how web applications work. Understand how the HTTP protocol works, because developers are building APIs these days and web applications, and it's a good thing for you to understand from a high level. You don't have to be an expert, but it's good to understand what developers are trying to do. Let's see, there's a question about branching, similar to GitHub and AWS. Can we enforce peer review and similar things to GitHub here? Yeah, there's a lot of parallels there. So you can have multiple branches, and it is just a Git-based version control system. So the things you can do with Git, you'll be able to do with code deploy. In terms of GitHub-specific features, Git code commit is newer than GitHub, so there may be some features there that aren't. There may be a lack of feature parity at this stage, so you'll just have to check the FAQs for the code commit service and documentation. What are the best practices to avoid configuration drift? Yeah, that's a good question. I think in terms of that, you really have to lean on a configuration management service if you're working with traditional servers. So configuration drift obviously happens where unintended changes to servers happen over time because of a mistake. Somebody logs in, they install something they weren't supposed to, and it impacts a configuration file or something. If you're using something like Ansible or Chef or PowerShell DSC, all those platforms have a construct there to help you with eliminating that configuration drift. So that's inside your virtual machines, right? So on the outside, at the infrastructure layer, you're talking about drift there. I would enforce security at the platform level and make those code changes go through version control. And so the way that AWS lets you set things up, it's very possible for you to just give people permissions to the version control repository, and that's it. And then the services are delegated the controls to actually do things. So that way you can ensure that only the changes go through version control. And you can do that for both the platform and the infrastructure as well. But it also means that the team has to be doing things right, and you have to test for that. So it could take some extra effort, but you can totally do it. We got about 5 more minutes, so I'm going to try to run through most of the questions. Well, I'm going to do about 2 more minutes of questions because I know we got to wrap up. But let's do this one here. How can we have AWS read an external repo like Bitbucket for CI/CD? Yeah, so when you go into code deploy, code pipeline, they have multiple options for different Git-based version control repositories. So I'd have to look and see which ones are currently supported. I know for sure GitHub's in there. Obviously, code commits in there. Amazon S3, because some people will put their code in S3 bucket. And I'd have to double check if Bitbucket is supported, but it might be. Okay. And then if you do find, if you do end up having a version control system that's not supported with code pipeline, you could probably find some exotic ways to kind of customize that or use a third-party tool in the meantime. Let's see. We'll take one more question, guys. Let's see. Last question, is there any certifications available for DevOps and any prerequisites? And I think this is a good question because yes, there is, and there's also some changes there. So the AWS DevOps professional exam has been out for a few years, and it's currently, if you were to go and take the exam today, they would put you in a version of the exam that was written a few years ago. There is a new version of the exam in beta right now that could come out anytime, probably sometime in 2019. So, one of the things that I'll mention is, I kind of mentioned it briefly, I do have a 4-course series here on Pluralsight. It's about 16 hours in total that covers all of the current domain objectives for the certification. So, if you want to get certified before the exam changes, I would check that out and just kind of go from there. And then outside of that, there'll be a new version of the exam published sometime next year. So there's tons of questions in here, you guys. I appreciate your time being here and sending these in. And like I said, if you want to hit me up on social media, connect with me on LinkedIn. hit me up on Twitter, shoot me a message. I'll be happy to work with you guys. And it might take me a while to get back if there get a ton of questions, but feel free to reach out and we'll kind of take it one step at a time there. Daniel, go ahead and take it.
Yeah, yes. Thank you so much for that excellent presentation, Mike. And thanks to everyone who provided their awesome questions. Like Mike said, we got a lot of great ones, and so we really appreciate that interaction. Mike, you've covered a lot of excellent material today, but I just wanted to give you the opportunity to share maybe one final thought or takeaway with the audience before we hop off.
Yeah, definitely. I would say go before the end of this week or into the weekend, go in there and spin up, get your AWS account if you don't have one already. Go into the Code Star service and launch one of those project templates and build out one of these pipelines and just kind of go around the version control repository, poke around, and just kind of kick the tires. Change stuff, watch it flow through the pipeline, and really just kind of integrate what you saw today, because you're going to get way more kind of things connecting in your brain if you get your hands on it. So that would be my big thing. Make sure after this that you go get some hands-on within the next week or so, and just use CodeStar to spin it up, and you can use the free tier. And then that's what I would recommend.